All right, so at this point, we have seen a few hydrohalogenation of conjugated dienes. And we know this reaction can give you either 1,4 adducts or 1,2 adducts. Okay, it can give you multiple products there. But now we're going to focus on the detail, who's going to be the major product. All right. All right. To explain that, we have to involve the thermodynamic controls and kinetic control and those stuff. Well, that's a lot of things to talk about. Now, let me keep things simple for you. Let's take a look at this hypothetical reaction. Let's say you have A and B. That's your starting material mixed together. There are two possible reactions or pathway that A and B can go. Pathway 1 making C, pathway 2 making D. Okay, and now let's assume that C is more stable than D, but D, read real quick. So a transition state is leading to D is more stable or lower activation energy than C, which means D is faster. If you're confused, what I just said, let's take a look at this diagram with me. Okay, so two possible pathways. Um, Look at this energy diagram. Which reaction, which pathway goes faster? Well, D, because lower activation energy. Okay, so the reaction that proceed more quickly to the product, that product is called kinetic product. Kinetic means speed. Okay, we're gonna say that's the king of the speed. So D is produced faster. We call kinetic products. All right, and now another question: which product is more stable? Look at the energy diagram. Well, you can see that the C has lower potential energy, so C is more stable. So we're gonna call it thermodynamic, the thermodynamic product. Okay, and in thermodynamic product, which means that the equilibrium constant from A B go to C is larger than the equilibrium constant that go to D. So eventually, so this reaction will produce much more C than D. Well, I can say much more. It depends on the K, the constant. Okay. So basically, this product favor the formation of C. That's my point. So C is thermodynamic product. All right. Now, don't get confused in here. So kinetic and thermodynamics are totally different properties, but they're not really. They're totally different properties. The fastest reaction doesn't mean that you get a lot of it, and the pathway to give you the more product, like in C, doesn't mean that it go fast. It could take 10 seconds. It could take 2 years. It could take million years. But eventually, when the equilibrium is reached, that product is produced in a large amount. That's a major product. Okay, so I'll give you some diagram right here. So basically, D is kinetic products. D is formed quickly at the beginning. All right, D is formed quickly. A is a starting material, A and B, so drop quick, so making D, and C is slowly formed. Right, if you let it sit for a while, the reaction moves toward equilibrium. D is lower and C is higher, right? Because all the equilibrium, they're all related, right? That go towards C. D that has been produced at the beginning break down back to A and B, and then C is missed after that. Let it sit up to, let's say, equilibrium. That's after equilibrium. So we end up with a lot more C than D. Okay, this shows that C is produced more slowly, but eventually you get more C than D. D get produced quickly, that's kinetic products, but eventually you don't get a lot of it because of it's not as stable as C. Okay, so some reaction, the thermodynamic product, the stable one, and the kinetic product, that's the fastest one, are the same. Give you some example: hydrochloric acid and sodium hydroxide. You guys mix them. There are millions pathway that this reaction can go. But if you remember, sodium chloride and water are highly stable. Water is everywhere. Sodium chloride is everywhere. These two products is highly stable. Right? I'll look at the energy diagram. There are millions pathway that hydrochloric acid and sodium hydroxide can go. But the more stable one is to go to sodium chloride and water, and the fastest one. Okay, how fast? Well, this reaction is so fast that the rate of diffusion is limiting factor. How fast is? I'm not so sure that you're with me right here. In order to do the reaction, the hydroxide ion and hydrochloric acid has to collide. right? And this reaction happened so quickly that the limiting factor is when hydroxide ion find hydrochloric acid in solution, they have to diffuse closer, and that's the slowest part. So this reaction is the acid-base reaction is the fastest reaction in the world. Okay, most of the time. Okay, so basically for an acid-base reaction, the kinetic products and the thermodynamic products are actually the same product. Okay, all right, we're gonna use this concept to explain the thermodynamic products and the kinetic products in conjugated diene system. Okay, let's talk about this on the next video.